Starting the stream. Hello. Let's see. YouTube does say that I am streaming. Okay. So this is my first stream. How's everybody doing? I was gonna do some coding for a project, so I thought might as well stream myself doing so. This is just as a proof of concept. This is my first stream. I don't know how is this gonna go, but hopefully everyone will have fun. So, what we are doing today, I am making a macro board. So, if you saw the thumbnail, uh, that is what I have already prepared. And the thing is that the power button on my PC broke. So I thought instead of fixing the actual problem, I I might as well create more work from myself. So I'm gonna throw a microcontroller in there. What I want is to be able to turn my PC on with either a physical button or my phone. So specifically today we'll be working on creating a web server for the ESP8266 that I'm gonna use. I already have done some work on it, but we'll see how that goes. Okay. Um, This is the PC-sided code that I have already written, but I don't think we'll be using that. Instead, we'll be working on the ESP code that is in another folder. Let's open that up. On recent ESP power button. Here. Okay, so I was actually using this library for creating the web server ESP dash. Let me open up my notes so I can bring up their website. Uh, Research. Here it is, ESP dash. If I click on that, let's see. Okay. So the interface for this looked quite nice. But when I tried to use it, the progress bar wasn't working quite right. Let me show you. So I have this right here, this CPU card. Uh, it is a progress card, so it should appear like this. Like when the bar should go up and down whenever the progress changes. But let me show you when I let me plug this in. So this is the board, if you can see that. So let's bring this up. If I connect to serial, reset this, I got an IP address. Copy that, go in there, and here it is. Look at this. The bar is not working. Uh, the percentage changes here, but the progress bar is not working. So I was thinking either I uh, switch to another library like like this one, ESP UI. Maybe set that. This one, or I can use a normal card like this, like a simple card that just shows some text instead of the progress bar because this is gonna annoy me. This bar not working is really going to annoy me. So this one looks better, but this has like this library like it always shows this buy me a coffee widget, and the top header always has this dash written on it. The ESPUI I can like control completely. I can change whatever text is in there, and I can uh, like show whatever text I want. It just doesn't look as pretty. Ignore that call. So looking at these both, I think even though this one ESPUI doesn't look as good, I might switch to this one. I have used this one in this library in the past, and it works nicely. So let's use this. Okay, I'm gonna close that. Let's see what we need to actually work with this. Library dependencies. ESP UI, ESP async server, ESP async TCP. I think I already have these two installed. Let's see. If I go here, let's close that. How big is the text? Should I make it bigger? That is too big. Okay, this looks fine. So the libraries. I already have the ESP async TCP library and the web server. These were the two, right? Yeah. First, let's strip down the all the ESP dash code that's in there. So the libraries gotta go. The server has got to go. The cards have got to go. We're gonna remove this fallback and this update code. So, and we can remove this. The instructions say just to put it just like that, I think. No, I don't think I will have to declare the author. Save that. Let's check out a example code. It is initializing the UI ESP begin. Is that it? Let's check out a few example codes if they have provided us samples. GUI, GUI.ino. Okay. So what do we have here? Um, okay, 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 okay. Where we go? Setup. You, I don't have to declare the async server in my main code, it seems. The library itself will handle it, apparently. Okay, so in setup, can you see it? This is too small for the stream, I think. Let me make it bigger. Okay, this should be clearer. Uh, where did the setup go? Okay, there we are. So this is just setting the debug level, enable the serial, set the host name. We can skip this for now. Wi-Fi.begin. This is the old standard Wi-Fi stuff. Okay, is that the end of setup or no? Yeah, that looks like the setup ended there. No, 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 no. It's still going. Oh, it's still going. Okay, 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 okay. So we start the DNS server here. We can skip that. Uh, this is just printing all the details of Wi-Fi, like the IP address and stuff. Hmm. Here we are adding, I think, the callbacks. Yeah, all the callbacks. We are defining the colors and then begin. Okay, in the loop itself, we have the DNS server. We can skip that. We can skip this. This is updating the graph, and this is updating a switch. Okay, let's check out these callbacks. Okay, we have the first parameter is always seems to be the label. The second one, if it applies, seems to be the callback. Let's compare this side by side with the button itself. If I, oh, okay, okay. So what we'll be using is just like a push button and some labels. I don't think we need anything else. Oh, we can plot graphs for the CPU temperature and stuff. Yeah, that's the other thing. The computer is gonna send the like some system stat like CPU percentage usage and stuff like that. So we can plot that on this graph, I think, instead of just using a label. That's an idea. So let's just get it up and running. We're gonna copy some stuff from this code here. Okay, the libraries ESP8266 Wi-Fi and ESP UI. Only these two we need to include. So if you go to main here, I don't think these are needed. No, we need the Wi-Fi library and include ESP UI. Will not be using this web server. The Wi-Fi code is fine. Will not be using this. That's fine. Okay. So what do we need to do to declare control? We want to add just the button, just a single button, and we'll go from there. Okay. So here's the button example. Hmm, yeah, the button callback is here. What is this? There's a button callback and a button example. Let's go to setup. What do we have here? Okay, we have this button. Let's just copy this as it is, and we need to declare this button callback. Let's change the name to power button. We can come here. We can how's the callback defined? Paste that in there. That done. How do we start this server? There it is. enough in the loop. We don't need to do anything special, I think. Well, let's see if this compiles. This is my only reason to disregard, it just takes really, really long time to compile. Okay, compiled successfully, no errors. That's a little strange, like nothing works for the first time, but I'll take it. Let's upload. Okay, I can see the LED flashing, so it's uploading. Okay, nothing on the serial. Okay, we got the address, right? That's 192.168.29.2. Okay, we got our UI. I can press that. How does this look in mobile? Looks just fine. Okay. Are we getting, the question is, are we getting an output on the serial monitor? Yeah, button down, button up. Works great. Let's connect this button to a LED. Yes. Okay. I have LED connected to GPIO forward, so I have to find LED pin. I think it is GPIO4. Let me double check. It's connected to D2. D2 is GPIO4. Yes, 4. Let's go to setup, pin mode, LED, pin, comma, output. And the negative pin of the LED is connected to the microcontroller. So digital right LED in to, for it to stay off, I'll make it high. Yes. Okay. If we go back to the callback, when the button is down, I want to turn it on, turn the LED on. Okay. Digital right LED pin. To turn it on, we set that pin to low. To turn it off, we can just set it to high. button, save that, and if I upload it, it should work. It took less time, I think, for compiling because we have already done compile before and haven't changed much. Yeah, compiled faster, but writing is still gonna take same amount of time. I think if I move the file system to like here, if I move the web files to file system, then this will take less time. But I digress. Okay, upload complete. Let's open the serial monitor. Name IP address. Refresh this. If I press, if that is working, the LED is not working. That's strange. Digital write, LED pin low to turn it on, LED pin high to turn it off. That should work. LED pin 4. Yeah, D2 D2 is GPIO 4. That is correct. If the pin is indeed connected to 3.2 volt, check that again. Yeah, it's working. The only the pin was loose. Okay, let's see. If I press this button, yes, that's working great. Okay, and my buttons that I've already programmed should be working too. They are not. Okay, these buttons I have that are already on the board should be. Okay. I remember. I think I increased the delay too much. Yeah, here it is. I can just remove this delay, save that, stop it, upload it again. Should work now, I think. Hmm. Next thing, I want to check out how the graph looks. Let's go in here. They have added a graph, I think. Slider, switch pad. Okay, here it is. Graph ID. How they updating the values? Just a simple function. And this variable, what is this variable? Graph ID. Just an integer. Okay, we can do that. Let's go. Uh, let's first check out if the keys are working fine right now. Refresh that. This is working. And if I press the button, yeah, it's working too. Nice. Okay, so we were adding the graph. Okay, let's it over and I want a CPU usage graph. So that will be CPU graph AD. Let's go to setup. Let's add that here. CPU graph ID equals to, or they added it. espui.graph. Let's just copy this. CPU usage. There are no callback functions for the graph, I'm pretty sure. Yeah, none. All we have to do is go here and use this. Control C. Okay, what we need to do is remove this delay. We should not be using a delays in a web server because if it's stuck on a delay, it might not react to our commands. But for now, I am going to use the delays. It should be random from 0 to 100. This is a CPU graph ID. This should be a name. Is that um, the YouTube is saying that the stream's audio bitrate, which is 0, is it 0? Let me check that. No, no, yeah, I can hear myself. No, no, it's working fine. Okay, so it should update the graph, but this will, without a delay, this will work too fast. So I think I'm gonna need that uh, delay with Melis function. Static long all Melis equals to 0. If Melis minus all Melis is greater than 500 millisecond. Update this and set all Melis equals to Melis. That should be how it's done. Yeah, close the serial monitor and upload the code. Hopefully there are no errors. Mm. Come on, come on, come on, come on, come on, come on. Checking. Way too slow, man. It's way too slow. Okay. Open the serial monitor back up. Should be connected. Let's check this out. Refresh the page. And we do have a graph. What's with weird numbers at the bottom? That's the time, I think. Yeah. Let's see if there is an option to change uh, this thing. Okay, others. Graph, 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 graph with a timestamp at which they arrive. There is nothing to. There are no other fallbacks, I think. Let's check in this program. If I go to CSP UI dot, let's see if there are no options in graph. Nothing. Let me hear who's calling me. I'm receiving a call. Okay, just telemarketers. It was a yeah, yeah. Okay. What options do we have? Add graph point, add control, update text, update slider, update page. Yeah, there are no options to change how the graph looks. All we can really change is the color, I think. Because even in their own uh, like showcase photos, the graph looks bad. And this seems like it will just keep compressing more points in the same size. It's not scrolling. It should be scrolling, right? I don't think it. There's a option for that. Let's see. Can we change something simple? Okay. Hmm. If this is the case, I don't think I'm gonna use the graph. If I refresh the cache, would the graph clear? Okay, nah, 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 nah. If this is how it looks, we are not going to use it. Let me in the ESP dash library. It also had a graph, I think. Hmm. Charts. It's a bar graph. Um, let's just uh, let's just use a label for yeah. There it is. Was it? Where it is? We're gonna remove the graph. Instead, we're gonna use a label. Okay. See, PSP UI dot label your CPU usage, the color, uh, just use the same color, the value, 0%, CPU label ID. I have declared this D script and we can come here and ESP dot. Here it is updating with ESP.print, but in the example, okay now, yeah, it's ESPUI.print with the label and the ID. ESPUI dot print. The CPU label ID. Okay, the string will be string. Actually, how can I do this? Int random, right? And then plus at the percent sign. I don't know if this is a valid code. I'm missing a few brackets. That should be fine. Okay. Let's see if it compiles. Seems like it will compile okay. Let's upload it. See how that comes. Come on, come on, come on, come on, come on, come on, come on. Good. On the serial monitor, it should be running. Let's check that out. It is. Refresh this. Okay, this is weird. What am I seeing here? Very weird. I think I should like create a string str equals to take this str plus equals space percent and then just use that here. Let's try that. Uh, Come on, dude, so slow. Okay. Open the serial monitor on the browser. Refresh this. Yeah, now it's working fine. All this looking mobile. Yeah, looks okay. And the button press is still working. Great. So now what we want to do is actually receive actual values from the computer and display those. First of all, I need to replace this delay. Hmm, how can we do that? What I want is to have additional, like a delay only when a button has been pressed, right? I want to continue the code otherwise. So, well, I added the delay between each checking. Instead, I can add the delay here too. Yeah. So let's say if delay if not delay active, not the bounce delay active, then execute all this code, right? Um, if the like we are not adding a delay for the debouncing purposes, then execute this code. Otherwise just wait for that whatever debounce time is set. So if like there has been a change in state, then we can set debounce Let me first declare this. Roles be static static role, and the default value I'll set to false. Okay. If there is a change, then we say that dbounce delay active equals to true or true, and we need another variable to keep the dbounce time actually. Long dbounce millis equals to 0. Dbounce millis equals to millis. Here we can just update this variable. If millis minus dbounce millis is greater than 200, which will be our dbounce time, we can set dbounce delay active equals to false. Okay, that should add that. Okay, let's just test this code by uploading first. I'm R, says hey bro in chat. Hello dude. Sorry I didn't see your message in time. Can I see the chat times? No, doesn't look like it. Yeah, I can see that. 5 minutes ago. Sorry I didn't catch you in time, bro. Let's open the serial monitor. Open this. CPU usage is working. This button press is working. And my physical buttons are working too. Doesn't seem like anything is executing twice. So the debounce is working also. That's cool. Okay. Next up, we want to receive the data from the computer itself. So let's open that program. Here it is. I'm writing this in C. So where are we getting the data? Let me zoom out of this. Here it is. I'm printing them to the serial monitor here. Right. So I want to print this with a like in a specific format. Let's first check out like what's how they're printing right now. Let me execute code. Let's open this in your file explorer. Oh, no. make that. Okay. App.exe port can't be opened. Okay, yeah, yeah, yeah. I have the port open in this process. Okay, so we're getting the like two the CPU usage. This should be the CPU usage. Let me double check this. The yeah, first thing is the CPU usage percentage. The second is memory usage, and the third is disk usage. The issue here is that this is not always going to be like two letters, right? It can be a single letter, or if the CPU usage is at 100%, this can be three letters. So we'll need to split it accordingly. First, let's prefix this with the thing else, like this. That's okay. Let's compile that code. Control Shift. Wait a minute. First, we need to stop this. Control C. Control Shift P to compile. There, finished already. Look how fast this goes. Uh, okay, let's go open the. Let's run it again, and we are getting this. Okay, so this we can use this like the this string we can use as a identifier in our Arduino code, right? Currently, this is printing in on the console, but instead we need to print it to the serial. How do we do that actually? Using read serial. Let me check if I have written. Yes, I did indeed store the. This is the reference that I used while writing the code. So what we need is writing data here. This is the part we need. Take this. Okay, we just need to replace read file with write file, and we have read C. Here we just need to replace this with the write file. Okay, so create a new function to write to serial. Write to serial. Void write serial. What we need to receive is the buffer. Can I uh, start off and the length? Yeah, the length of the string that we want to write. We can just copy this, paste that here, replace read with write, hcom is fine, ch with buff, tw word, what is this? Control C. We save that and it should be all right, I think. Yeah, let's can go in here. We need to store this in a char buffer. All this string that we have into a char buffer. How can we do that? Let's just let's just search it. This is okay. C++ printf to char buffer. The IDE I'm using is VS Code. Fourier is asking which IDE I use. I'm using VS Code. This is the one you're asking, right? This is Visual Studio Code from Microsoft. It is free. You can get it. Pretty good IDE. If you're using what I'm using for Arduino, this is a extension called Platform IO that is being used for the Arduino work. Okay, uh, we were checking out how to printf. Okay, this is doing opposite. It is writing a char array using printf. No, no, no. I want to write to a char array. How can I do that? Uh, see, what can I say? What can I say? What can I search? Let's just see C++ Spring. Okay, write to it. Printf to Spring. They are all using formatting function. I don't want to use that. Okay, this is what I think I'll be using this printf. So we need to look up this function printf printf C++. Okay, and there is the char buffer. Okay, but in this we'll have to like define the length beforehand, which I don't want to do. But maybe we can just make it longer than it needs to be, and it will work out. Yeah. So we can do a char buffer of like we'll never use 50 characters, but okay. And we can do printf. We are saving to buffer, and the format is this control C, control V. This is correct, right? Yeah, looks correct. Okay, then we can write serial. Okay, what does this return? Okay, so we can go int length equals to, and we can send the buffer comma length. This will hopefully work. Let's compile it, see what happens. Error, we got an error as expected. Okay, right Siri was not declared. Okay. Let me grab this. We need to declare this the top. I have my declarations here. So this, compile it again. Okay, built successfully. Now, when it outputs to the serial, we need a way to check if the output was like correct, like if it is actually outputting. So how do we do that? Because the serial is connected to the ESP. We can grab the RX of the ESP and connect it to like a USB to TTL adapter. Let me see if I have one. Oh, the tablet just fell over. Let's see. I don't think, yeah, it's gonna be hard to find it. Let's just modify the ESP's code uh, to, let's first just check if this one executes correctly. Okay, this is executing fine. Um, let's just modify the ESP's code. So serial dot read bytes, no, read string. The character is like, and what does this output? Uh, string, okay, string text equals to, we need to like wrap it in a, with serial dot available. We can like add another label and serial read ID. Let's create another label. Let's just copy this. Serial read ID ESP label serial and oh, oh, can just say default value we NA. Okay, and we can update this here. It will be ESPUI dot print serial read ID comma text and send it to the ESP. Oh, I really hate this, but this takes so long. Come on, come on, you can do this. You can do this. 47, 52. 71, 80. Come on, come on, come on, come on, come on, come on. 100%. Okay, on the serial monitor. Anything? Is this not executing or what? Okay, this is working. Let me kill this. Open the browser if I can find it. There it is. Okay, and we got like any on the serial. Let's see if I run the CPU command. Yeah, we're getting stuff. Cool, 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 cool. Now what we need to do is parse like the string to get the like the CPU value, the memory usage, and the hard disk usage. So let's go to power button here, and we are receiving the text here. So we need to parse this string. First of all, we can do uh, text dot split. Can we do this? Substring. Let's see what functions are available to us. Let's see. Arduino String. What we want is like a split function functions. Vector. Hmm. We just split, not there. Uh, sure. String null terminator is a string. No. This is not what I'm looking for. String. Okay, here are the functions. Caret compared to concat, replace, reserve. Okay, what I need is to find a like find a substring that gets a substring. No, it's not what I need. Index of locates a character or string within another string. Okay, this is what I need. Okay, okay. We want text index of what were we getting? Systat. Actually, just get the index of this. We don't need the whole thing, right? We can get index. And if index is not equals to -1, then what we can do is move further. We wanna get the text dot index of the first slash t character. Then we can get CPU and CPU percentage equals to text dot substring beginning index is, but is the substring inclusive? It is. The starting index is inclusive, so we need to remove that. And ending index is exclusive. So we can set text.substring index +1 equal x comma, and the end index. So what's the issue here? No suitable conversion from string to int. Yeah, just will this work? I thought so. Will this work? Uh, Actually, I don't think we need to convert it to. Yeah, we don't need to convert it to integer. We can just keep it a string and then just print that string as is. Next up, we need to like set text equals to. We need to remove the part from the received string that we have already used. That is the CPU percentage thing. So we can do text is equal to text dot substring, and can go text dot substring. We are using /t as indicator, but co plus one. So we won't have /t in there. And I think that is all we need. Okay, what's the issue? Okay, we'll go index of. That looks messed up. We are getting string uh, memory. Yeah, message percentage equal to text dot substring 0 comma the end index. So we can go text dot index of the next /t. Yeah, and the last one string by disk percentage equals to, you can go text dot substring text dot index o /t comma just till the end, right? Yeah, save that. These will be correct, I think. Only one way to find out. Let's remove this label, change it to something else. CPU label ID, and no, we already had that. What we need is memory label ID and uh, this label ID. Add the labels, remove this, copy the CPU usage. You can change this to memory usage and We can change this to this usage. Cool. Now we need to update it. Actually, move this, I think. Um, can go here like when everything has been done. Right, we have after we have extracted everything, then we'll update it on the server. So we can go CPU per plus equals to a space and percent sign. Right, we need to do this 3 times. Them and this. Okay, this is now we need to update all this. So let me actually remove this. Wait, that separate. This is CPU or CPU with none and should compile all right. I think there are no errors. Last famous last words, but there is a warning, not an error. Um, unused variable. Okay, okay. Yeah. Let's let's upload them. Um, comport is not open, right? Yeah. Mhm. Why so slow? That uploaded correctly. If I refresh the page, there are 3 levels, and if I start sending the data, it should have started updating. Yeah, I am getting my okay. There are some errors. Yeah, I think I'm getting my CPU usage in the disk usage thing, and I'm not getting the rest of them at all. So that needs to be changed. Um, let's stop this. Let's check what are the issue here. I think I need to recheck the documentation. So uh, it's not saying it should be giving me the correct index. So that's not the issue. Uh, we get the text. We find the index of uh, this character here, right? The colon. Then we extract the substring from this here, the next character, right? Index plus 1 and the index of slash t, which is not inclusive. So we'll only get these two characters. That is how it should be. Next, we take the string and extract the substring from this plus, right? The first slash t plus. So here we'll have this string next. Then we extract the substring from 0 to next slash t, so these two, and then we extract from this. It should be plus 1 here. But that in itself not have given this error that I'm getting. First of all, let's replace these with single inverted commas. Okay, let's try that again. Serial port is not open. Okay, let's upload that again. We'll see if we can do better this time. Hmm. I also need to reduce the uh, update time on my system stats that I'm sending. They are going way too fast. So I think I'll add a delay here of 500 milliseconds. Yeah, that should be fine. Let's recompile this. Hit that. Just finished compile. Appears so. Uh, we have uploaded successfully. Let's refresh the page. Okay, and now if we start sending the stats, again we are only updating the disk usage thingy. This is bad. Hmm. Why are we getting this value here? I don't know. Pretty weird. Let's let's see again. Okay, we are printing to disk label ID disk percentage. Okay, let's just confirm we have written the correct things. Okay, okay, here's the issue. Here is the issue. Uh, this is mem and this is this. Okay, let's try that again this time. Okay, it should work now. Just make sure the serial port is closed. Yeah. If you guys have any questions regarding what I'm doing or whatever, you can ask. Feel free to ask in the chat. Okay, the upload is complete. Let's refresh the web page. Okay. And if I try this now, yes, yes, they should match. Now, the text might be too small. Let me see if I can make it bigger. Okay, see this. Yes, this is the CPU usage up top. This is the memory usage. This is the disk usage. And we can actually compare this thing with the task manager. If I open that up, they should be pretty close. Only the CPU usage will be like drastically different. Otherwise, they should be pretty close. Yeah, seems to be working just fine, I think. Let me reset this. And if I press the button, the light works. And if I press the physical button, the input should go through, but is not. Okay, okay, it's going through. It's just slow. Yeah, that might be because of the delay that I had in here. No, in here. This I should not use a sleep function. But the question is there a equivalent in actually we can just move this thing, control X that, and we can move this to here. This can only executes every 500 milliseconds uh, because of because this is running in multi-threading, so this can work in parallel. So I can remove this sleep function from here, and it should still work fine. Let's close this. I mean, stop that. Compile this again. Yeah, that's working. Okay, and if I execute this again, said like this is printing faster, but the actual text that is being sent to through serial should only go every 500 milliseconds. Let's open the browser if I can find it. There it is. Okay, right. This is working fine, I think. Yeah. And now if I've sent the button, they should come across instantaneously. Yes. And these are actually being simulated on the keyboard as if being pressed from an actual keyboard. The keys I'm sending are F13, F14, F15, and F16. They don't actually exist on the keyboard, so it shouldn't like collide with any existing macros that might exist in any program. So let's stop this and let's remove this printf function, and I can demonstrate to you the key presses are actually working. So compile this again. So what's the best way to show macros? I guess I can change it in my OBS so that when I press a macro, it switches scenes. Let's go to settings. I can go to hotkeys and switch to screen here. Yeah, so I can set like if this is compiled, okay, I can run that. And if I press the button, yeah, the key braces are coming through. So let me show you. If I bring in the settings here, I can say switch to scene if I press F13 and the one I am using right now, desktop right, F14. Oh, if I press that, then it should switch. Yes, they're working nicely. Right. Let me go back to my normal scene. Okay. What else is left? Uh, I think we are like done. I need to add this inside my cabinet now, the PC case. If you want to see how the hardware looks, this is wow. Uh, right, these are the buttons, and I can like this should switch to cam. This should switch me back to the desktop screen. Working pretty well, and I can like see my stats in the browser window, and I can control this like for now this is just an LED, and if I press this button, this should turn on. Right, you can see that, right? As long as I hold it down, the light LED stays on and off. So this LED is gonna get connected to my the power pin that is on the motherboard. So it will replace my, not replace, I'm gonna connect it in parallel to my actual power button, which doesn't work reliably. And I get other keys like for and like I still have a lot of pins available to me on the micro that I can add other keys to. So this has worked surprisingly well. I don't think I have anything else left to do today. Yeah, I also wanted to add CPU temperature to the stats, but the library that I'm using, I don't think it provides that uh, reading to me. Uh, the library is called, should be, yeah, this PDH, Performance Data Helper, I think it is called, but I don't think it provides like the temperature. We'll need to check. Let's find out. Uh, PDH CPU temperature. What is WMI? They are referring to WMI. What is that? This might be the thing that I'm using to actually get the current total memory value. Take a second, just let's go in here. Total system memory. Uh, there it is. So, like, if I just start typing like CPU temperature, like if I just type temperature, will I get anything? Nah. Let's see. Get. What did it say? Get CPU computer. Global. Nah, I'm just not gonna like hit the goal if I keep searching random sounds in. Let's check this. WMI. Here too they are suggesting WMI. What is WMI? This is the library I think they are talking about. Dude, that's a long code. I think I'm gonna leave the temperature alone for now. It's just not worth the effort. The rest though is working great. So I think mm, what else should let me just check this one more time. Man, this is so fun when things work out the way you want them to, right? So cool. Okay, I think it is time for lunch too. I think I'm gonna end this stream here and I'll add this into the computer, wire everything up, maybe add a few more buttons to this, but I'll do all that off stream. Thanks for tuning in. If anyone tuned in, I mean, I got like 2 messages in chat, so that's great. And I'll see you next time.